Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 42, number balanced integers in the range. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, this is, to give you a little bit of a context, I did this in about 10 minutes, and honestly, it even felt a little bit slower. But the reason why I was getting it so fast is not for any particular reason, except for that the last couple of contests, or not just couple, but like say the last 10 contests, there were like 3-digit DP problems, right? So at a certain point, you get enough practice, and I think that's why I'm a little bit fast. So it is kind of awkward for me because like I feel for this video, I'm not gonna lie, just to give you the context, is that because I've explained the same thing like 3 different times, and if you're watching from the future, you may not know what I'm talking about, and that like you didn't watch those videos maybe, then you're like, well, this is not useful at all because So let me know in the comments, but maybe I just need to do 1-digit DP video, kind of just to go over it. But yeah, but this is digit DP. What is digit DP? Well, digit DP is basically doing DP based on the digit 1 digit at a time, right? The number 1 digit at a time, and this is a very standard thing that I don't know. I mean, I don't know if it's standard actually. I take it back, but Leetcode have been asking that a lot, for whatever reason. Maybe they just run out of ideas. Okay, but let's do a couple of things. We'll go for this. First of all, right? You're given a range, or you're trying to find the answer for a range. To calculate the answer for a range, use prefix sum, right? And what I mean by that is that, okay, let's say you want to find the range of answer from low ... all the way to high, and you can think about this as like you want to try at every number, right? Well, for every number, you can say return either 0 or 1, right? And once you do that, then you can look at this as a sum, right? So then now you're looking at these 0, 1 sums from low to high. And then and I know that people, at least when I was younger, I haven't done this in a while, but when I was younger, I was practicing this where you do both DPs at the same time, or both the low and the high in one DP. But I don't know when you might. I mean, maybe certain cases it may be necessary, but I don't know. But yeah, I don't know. But the idea is just that if you kind of look at the low and high as ranges, then now, and you have kind of this idea, then now maybe you could define f of high. Let's go by high like this. Is equal to, let's just say, let's call this function g, right? G of 1 plus g of 2 plus ... plus g of high, right? And then f of low minus 1, and I'm going a little bit fast, but hopefully you'll follow me anyway, plus ... plus g of low minus 1, right? And then basically if you take f of high minus f of low minus 1, then it is equal to, the 1s cancel, 1, 2 cancel out all the way, all the way, and then the next number, of course, that doesn't get canceled out is g of low, right? Plus ... and so this is equal to g of, man, my handwriting is terrible. I blame it on the keyboard. Low plus g of low plus 1 plus ... g of high. And that is the answer that we're looking for. So this is very quick. This is some background. You need to know this for this problem, right? And then digit DP. The idea behind digit DP is just doing it digit at a time. So now that you kind of decompose this problem into of 2 parameters to 1 parameter, or 2 arms of 1 parameter. Let's say you want to count like, I don't know, 2,579, right? So we basically want to, the idea behind digit DP, and I'm going to go over the more general version of digit DP before doing this version, is just do 1 digit at a time, right? So now we brute force on the first digit. It could be 0, 1, or 2, right? Well, if it's 0, what does that mean? That means that all the numbers after that is possible, right? Same as 1. Well, with 2, it can only go up to, in this case, 5, right? So it could be only 0, 1, 2, 3, 4, 5. But then after that, on the 0, 1, everything is possible. On the 1, 3, 2, 3, and then but the 5 can only go up to from 0, 1, 2, 3, 4, 5, 6, right? And basically, you're just doing a recursion based on this logic to kind of brute force or enumerate and brute force all the other ones. The key thing to note for digit DP is that in this case, some of the states will be the same, right? I mean, it may not, depending on the particular problem, but for example, maybe, you know, if these two states are the same, then you save one core already. And there are other stuff like that, but that's basically the idea about digit DP is that you're doing it for all the number, but the number only changed the state in certain ways that you can reuse the overlapping subproblems, right? Okay, so that's kind of the digit DP idea in like 20 seconds or whatever. Hope that, you know, if you haven't, there are a lot of easier digit DP problems, so definitely if you struggle with this one, try an easy one first, right? I mean, I think that seems like a reasonable suggestion. Okay, so then for this one, the three standard thing for me, and this is just me from the last couple of contests, is just, you know, the index, right? That's the state, and that makes sense, right? Because I mean, that's just very standard. You have 5 digit, you're doing 1 digit at a time. That's the index. The second is prefix, right? So the prefix for me just means that whether it is matching the prefix. For example, the 0, if we choose 0, then this doesn't match the prefix anymore. That means that we have freedom to go anywhere we want. But if we choose 2, we can only go up to 0 to 5, so it's still matching the prefix, right? So that's basically, this is saying for this given index, it has matched the prefix so far, right? So maybe you need to use it, maybe you don't. Okay, and then the other one is leading 0. This may or may not be super needed. Actually, I don't know if this is needed for this one. I just kind of, yeah, maybe it doesn't really matter for this one. But I just kind of always just write it in. Maybe we'll solve this problem later to see whether this is necessary, if you remind me. But yeah, leading zeros. Sometimes the leading 0 does some weird things. So yeah, it just kind of, I don't know. So that yeah, so it does some certain things. Maybe this is not necessary for this one actually. Okay, but for this one specifically, there are, the only thing that I added is this idea of delta, right? So because this problem, you want the odd and even digits to have the same sum, right? And there are a couple of ways you can think about it. The actual odd and even doesn't actually matter, just that we match up every other number, right? So here, and the way that I count delta is just that on the first digit you add, and then the second digit you subtract, right? But if they're the same, then delta should be 0, right? That's it. Yeah, that's basically the entire idea. Okay, and that's basically, yeah. And then after that, it's just about enumerating all the cases, and we'll go over the code now. I think but before I do that, actually, it's just well, I'll show the code, but what you should also do is calculate the complexity, right? But the thing was that for this one, the constraint is 10 to the 15, which means that they're 15 digits. So usually for digit DP, I don't really worry about the complexity too much, just because like if you look at this, as we said, index goes up to 15, so maybe the 16 numbers. Prefix is binary, leading is binary. Delta is maybe the tricky one. You have 7 number, you have 15 numbers, half of them, so let's just say 8 of them. 8 of them can be 9, and then the other is just 0, right? So then that's 72. So maybe it could be 70 plus 72 and negative 72. So that's 144 difference, maybe 145 if you really want to be precise and inclusive and stuff like that, right? So, but that's still like 15 times 2 times 2 times 145, and then there are loops that does 10, so you are pretty Gucci. And I'm not gonna lie, I think I did fall into this thing where I've been just doing so much that I do jump into this leading zero for no reason. So now I'm trying to think whether that's even necessary. But okay, we'll go over the code as it is written, and then maybe we'll upsolve it, right? But that's really the core idea, is that we're just trying to brute force digits one at a time, and then just how it shifts the state, right? First of all, we have this thing at the bottom, and it's exactly what we said, which is that high minus this thing, low minus 1 to get low to high inclusive. And then now I always convert it to a string, just convenient, and we get rid of 0, just, I don't know, just seems pretty basic. But keep in mind this also counts the number 0. You can maybe change the base case. I just kind of remove it in this case because 0 is always balanced. I don't know, doesn't matter, right? But yeah, so given index, prefix, leading, delta, we have the base case. The base case is we used up all the digits. If the delta is 0, then we have one good number. Otherwise, we turn 0. Just normal base case things. Otherwise, we just choose another leading 0 again. Maybe this is not written precisely for this problem, but you know, we just choose another leading 0. Okay. Otherwise, C is the current digit. And then sign is just that, you know, as we said, we want to either add or subtract. So that's just how I wrote it, so that it's just a little bit easier, so I don't have to add more if statements later on to like add to delta or subtract to delta. But it doesn't really matter. You can easily do an if statement, right? Do whatever it's more comfortable for you, for sure. Keep in mind that this is slightly less performant, right? Because we're doing a multiplication, but it's not a big deal. Yeah. If we're watching prefix, then you only go up to C. And then for numbers that are less than C, then we no longer match prefix. We also skip leading 0 for this reason, so maybe this is not necessary, as I keep saying. But this is for C exactly, then we have true. And then the contribution, of course, is that we have the sign, so it's either add or subtract, given the I, right? And then if the prefix is not true, then we just try for every digit. Keep in mind that we have this here because we already did this, is the reason, but again, maybe that's confusing. But that's basically it, really. It is kind of straightforward, I want to say. But yeah, we already kind of went over the complexity. It's just that it's fast enough. But you could say it's n times 2 times n times 2 times 2 times delta, and delta, of course, is going to be 9 times n, so that's actually n, right? That's actually n squared times 2 times whatever. Or I guess 18 times n, actually, but you know, or 10 times n, whatever. But still n. And each of them has at least, or at most, 10 for loops. You could also maybe substitute some of this for like d for the number of digits or something, but it's fine. Okay, that's it for the normal portion. I am going to upsolve this with no leading. Maybe I just kind of mentally templated this in because I've been doing it so much. I didn't really think about whether I need it. So okay, let's just say we remove this and we don't even need this, right? Right? And then we just kind of take I as an other normal number. Would that work? That didn't even say. I don't know why this is so weird. Oh, is the contest still going on? I guess so. Why is it not giving me my answer? Or like my results? Okay. Alright, let's get a quick submit. Yeah, okay, so yeah, the leading 0 thing, sorry for the confusion. It's just that it comes up a lot for some reason, maybe recently. But apparently you don't even need it, because, yeah, as I looked at it, I was like, this doesn't really change the number of anything. So yeah, so all you need is for this one is index and prefix and delta, and we just made our code 2 times faster or something, maybe, or two times fewer state anyway. Maybe not, actually, because leading is really true. I mean, it's not a big deal, but how much faster it doesn't say for some reason. Yeah, slightly faster in any case. But yeah, that's it. That's all I have for this one. And yeah, you can actually even fit most of it on one screen once I make it smaller. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve a live in contest now. Okay. Yeah. Still struggling with reading apparently. We have a 7-pointer. We have an hour 20 minutes, so we're doing good on time, I think. I mean, I don't know why I look at the rankings. It just depresses people with all the AI leaderboards. Okay, number of balanced integers in a range. An integer's called balance if it satisfies both the following conditions. It contains 2 digits. I just gotta read it. Okay. I mean, is this a digit DP? I didn't even finish reading it, but okay. Balance, okay. The sum of the digits and even. I feel like I've done this before. Leftmost digit has position 1. Okay. That's actually kind of annoying that they do it by left digits, but or most significant digit. But okay. I mean, this is clearly digit DP even before I finished reading, but right. Okay. At least 2 digits. Sum of digits at even and sum at odd. I mean, it's just digit DP. I don't think it's fine, right? And I've been getting better at digit DP just because there's so much practice that they give you. Okay, and now, how do I write this again? With the index, we have whether the prefix matches. Leading 0, say. Is that it? No, sum of. Just go with delta. Right? Yeah, I think that's fine. G of 0 prefix is true, I guess. Leading is true. Well, leading is okay, and delta is 0. Okay, so if index is equal to n, if delta is equal to 0, we return 1. Otherwise, we return 0. Right? Okay. Otherwise, then now, yeah, if prefix. This is why I usually separate them out, but maybe this is fine. Okay, how do I usually write this? If the leading 0 is still going, then we can index plus 1. Prefix is no longer true, just by definition true, and then delta. Though delta would be 0 probably, but if prefix is true, then we do for in range of okay. So the current digit is s sub index. Right. So that does not include C. So for the current digit, I always like to keep the for loop, even though maybe in this case maybe it doesn't matter. Well, actually, this one you do need the I. We do use the I. Okay, so G of index plus 1 for force. That's true. Force, and then now delta. It's plus I. I mean, I guess it doesn't really matter. It's just about as long as you're consistent. Doesn't matter which one's odd, which one's even actually. As long as the parity matches. So sign is equal to 1, if index mod 2 is equal to 0, sign is -1, right? So then plus sign times I. We skip 0 because, do we skip 0? If we are doing leading 0, then we skip 0 because we already did it. Leading, then we continue. Leading and I is equal to 0. Maybe I need to clean up my mental template or whatever. Okay, and then now if no, I think this is fine. This always exists, right? I'm not making this up. True, false. Okay. Otherwise, this should be actually on the outside. If we use this anyway. If it's leading prefixes, no, that's not true. I don't know. Don't have to think it through, but let's just type it out for now. False. I think that's it. Did I remember the cache? I did. Okay. Alright, I mean, this is close, but not quite. Why did I get 8? Did I miss a number? I think it's because I count 0. So it has to have, yeah, because I think I count, no, but, that should have cancelled out, actually. Well, maybe this returns 1, actually, for f of 0. No, it returns 2, which is even weirder, actually. Should not return 2. I mean, this... let's say it's -1, but why is 1 of 0? Oh, because if it's 0, then it does match the prefix some weirdness thing. Okay, fine. Just have, okay, fine. If x is equal to 0, return 0. But otherwise, 1 digit cannot ever do it anyway, I don't think. I'm not super confident, honestly, anymore, but there could be some minor silliness, but we did it pretty quickly, so okay. I was gonna say, yeah, we did it pretty quickly. I could mentally eat the wrong answer. It's fine, but yeah, I think so. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, this explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.